Okay, Bismillah ar-Rahman ar-Rahim. We'll start 3.5, implicit differentiation. And as usual, we'll go over now the basic, and that's in this section. And then we'll go to more problems. We have two things in this section. What's called implicit differentiation, which are methods to do the derivative. Now, if I have a relation or an equation in x and y, how will differentiate dy? How to find dy over dx? We differentiate both sides with respect to x and treat y as a function of x. Simply, if I have d over dx of 3x square, what will be that? This is, since I'm doing it with x, this is function of x, that will be 6x. However, if I want to do d over dx of 3y square, I want to do the derivative of x in terms of y. So I'll do chain rule. That will be 6y times derivative of things inside, which is y times y prime. Then we just solve for y prime. That's what's called implicit differentiation, which is usually if I have a relation or the relation between x and y, it's written in an implicit way, not in an explicit way. It's not y equals something in terms of x or function of x. No, I have a relation between x and y. Combination f of x and y equals 0. Combination of them is equal to 0. Okay. And also we have something called logarithmic differentiation, which is another thing. This is usually, we do it if we have expressions involving products, quotients, powers. So try to use the properties of the logarithm to simplify the function before I do the differentiation. That's mainly the idea. You know that len function or x times y, it's len x plus len y, provided everything is defined. So instead of dealing x times y, you can deal with x and y. So it will make the calculation easier. And also len x over y, as I said, provided everything is defined. Len x minus len y. Len x to the power r, this r can be a number, or can be at the beginning. That will be len x, r len x. Now, it's instead of doing the derivative here, I will do the derivative here. That will make it easier. So the steps are this. Take the len of both sides, use the properties of len to simplify the expression, then differentiate both sides implicitly. Now I have a relation between x and y. Implicitly with respect to x, solve for y prime. I have this case, f of x to the power g of x. Usually logarithmic differentiation, if we have a function to the power of function. Actually, if we have, just as a review, if we have constant, now I want to deal with this, with all the four cases, where f can be constant or non-constant, and g can be constant and non-constant. We have four cases. Constant to the power constant, خلاص. So this will be constant, derivative is 0. Function to the power constant, how to find the derivative? Chain rule, n, the function to the power n minus 1 times f prime at x. Constant to the power function, constant b to the power g, b constant to the power function. It will be the constant to the power the function, len of b times the derivative of the function. The last things, which is function to the power function. We'll use the logarithmic differentiation. We'll see examples. The last things in this section, the normal line. What they mean by the normal line is a line through P, through the point of tangency, but it's what? Perpendicular to the tangent line at P. The normal line is perpendicular to the tangent line. So what happened? Their slopes, its slope is the negative reciprocal of negative line. So I have M tangent times M normal is equal to minus. Yeah. That's all for this section. This is what we have mainly: implicit differentiation, logarithmic differentiation, and the idea of the normal line. That's what we have in this section. So let us do some problems. Find y prime if sine of xy equal y squared cosine x. Very clear. It's an implicit equation. So do the derivative, differentiate with respect to x, differentiate with respect to x. Now we'll come to this. Sine of something. That will be cosine of that things times derivative of this. I want to do a differentiate with respect to x. What's the derivative of x? It's 1. What's the derivative of y? It's y prime. Equal. What's the derivative of y square? It will be 2. Now it's a product. Huh? I have product of two functions here. I have y squared times cosine x. So the derivative of the first, 2y, y prime, times cosine x. Plus y squared, derivative of cosine, which is minus sine. Look, when I deal with y, I need y prime right away. Now, combine the ones with y prime in one side, solve for y prime. Roughly solve for y prime. So that will be what? Cosine x plus y prime cosine x plus y. I can take, yeah, this is, make it 2 steps, who cares? Cosine x minus y squared sine x. The one in y prime, this and this, so I have y prime cosine x plus y minus, I took this to the other side, 2y cosine x. And that should be equal, take this to the other side, minus cosine x plus y minus y squared sine x. So what will be y prime? خلاص. Minus cosine x plus y minus y squared sine x over this, which is cosine x plus y minus 2y cosine x. That's it. Or if you want to simplify it, you can write it cosine x plus y squared sine x over the 2y multiplied by minus, both in the numerator and the denominator. Or I divide by minus, the way you like it. I hope it's clear. That will be y prime. Both are correct. Okay. Now, do one more problem also. Basic things. Huh? I'm doing the basic things to be sure the things are going fine. What is y cubed? I have 3y squared, y prime. What is y squared? 2y, y prime. What is 5y minus 5, y prime? This is minus 2x. Because I'm differentiating with respect to s. Differentiate with respect to x. What's the derivative of minus 4? 0. Now the thing with y prime, 3y squared plus 2y minus 5 equal to x. So what's y prime? 2x over 3y squared plus 2y minus 5. That's it. Find dy over dx for these functions. Let me do it one by one. First one, x squared plus y squared equal 1. Differentiate with respect to x. As usual, every time we differentiate with respect to x, we'll have 2x plus 2y, y prime, derivative of 1, which is 0. That means y prime equals what? Minus 2x over 2y minus x over y. That's it. So I'm trying to get y prime in terms of x and y. 2. Here I need to differentiate also with respect to x. What will be that? Derivative of the first. Now I have product here. So it will be 2x y squared plus x squared, derivative of y squared, which is 2y, y prime, plus 2y prime, plus 4 equals 0. The one with y prime in one side, the one with no y prime in the other side. So I have what? 2x squared y plus 2 times y prime equal minus 4 minus 2xy squared. I move these two to the other side. So it will be y prime. Y prime will be minus 4 minus 2xy squared over 2x squared y plus 2. In other words, I can take minus, can take 2 common factor, I divide by 2 everywhere, minus 2 minus xy squared over x squared y plus 1. Okay. You just take 2 as common factor and cancel it. Okay. The third one, let me write it here. Y to the power 5 plus x squared y cubed equals 1 plus y ax squared. Okay, differentiate with respect to x. What you will get? What's the derivative of this? 5 y to the power 4. Don't forget y prime. Plus, here I have product. Derivative of the first, 2xy cubed. Plus x squared, derivative of y cubed, 3y squared y prime. Equals 0. Here I have product. So I have y prime, ax squared, plus y, ax squared, derivative of this, 2x. Now combine the one with y prime in one side, the one with no y prime in the other side. So I have y to the power 4. I have this, and this. This is the one with the y prime. Minus 3x squared y squared plus, not minus, sorry. This is minus ax squared equals, this is 2x y ax squared minus 2xy cubed. I move this to the other side. So I change the sign. Oh, I forget. Yeah, this is times, let me give it some break, times y prime equal the rest, which is 2xy ax squared minus 2xy cubed. So it will be y prime plus 2xy ax squared minus 2xy cubed over 5y to the power 4 plus 3x squared y squared minus ax squared. Okay, number 4. What is it? Sine of x squared y plus cosine x equals 1. Correct? Yeah. Differentiate with respect to x. What you will get? You will get cosine x squared y times derivative of this, product rule, 2xy plus x squared y prime minus sine x equals 0. The one with y prime on one side, the one with no y prime on the other side. So I have cosine x squared y and x squared times y prime. This is in one side. Or you can simplify this. This is 2xy cosine x squared y plus x squared cosine x squared y times y prime minus sine x equals 0. So this is the one with the y prime. Move the other ones to the other side. That will be sine x minus 2xy cosine x squared y. So it will be y prime would be sine x minus 2xy cosine x squared y all over this x squared cosine x squared y. That's it. That would be the derivative. Yeah. Yeah, this is the idea. Present y as a differentiable function of x. I want to represent y as a differentiable function of x for these cases. Okay. Notice for a, what is this? It's only a point. When x squared plus y squared is equal to 0, there's only a single point. So this does not define y as a differentiable function of x. Okay, since it's only a single point. Now, case B, x squared plus y squared equal 1. Okay, what I will do, I can solve for y. What is this? This is a circle. This is a circle with radius 1. Okay. Now, what will happen when you find the derivative? I need to take it over some over some interval. Yeah, let me do the calculation and then I will explain it. I have y squared equal 1 minus x squared. So I have y equal plus or minus square root 1 minus x squared. So I actually have two functions. This is one function, and this is another function. And we notice at these points, here 1 and 0, and this is minus 1 and 0, f is not differentiable. The slope is undefined. Why? Took this one. If we take this one, what will be y prime? 1 over 2 root 1 minus x squared. Here I have minus 2x. So it will be minus x over square root 1 minus x squared. But I need 1 minus x squared not equal to 0. So the slope is undefined here. So the function, to make it differentiable, I should take a period where there is no stop. I mean, I cannot just jump over this 1 point. So either I will take the upper side or the lower side. I cannot take both. So I have two functions, y equal square root 1 minus x squared, where x between minus 1 and 1. I know at 0 there is a problem. At x equal 1, I mean, which is square root of 0, because it will make a problem with the derivative. So I make it, and this is the upper half. This is the upper semicircle. And y equal minus square root 1 minus x squared. Still by x minus 1 and 1. Y should be negative, and this is the lower semicircle. You cannot take both. So it's defined. These two are defined as defined as a differentiable function of y. Let me take part C, which is what? Which is a parabola. Huh? If you graph it. So it's a parabola. It is this parabola. Okay. So I have what? I have this point, which is 1 and 0. There we have a problem. Y, think about it, y squared equal 1 minus x, y equal plus or minus square root 1 minus x. So we'll do the same idea. If y equals square root of minus x, what will be y prime? It will be 1 over 2 root 1 minus x. Don't forget times minus 1. So x at minus 1, I have a problem. X not equal to not equal to 1. Here I have a problem. The slope is undefined. Same problem as in this one. So it means to make it differentiable, I need to make it y square root 1 minus x, where x less than 1. I cannot define it at 1. And this will be lower half. I'll take either the upper half, this is the upper half. I'll take either this or this. I cannot take both. As we did here. And I mean, yeah, we take either this or this. Same thing, either we'll take this to define it or this to make it differentiable, because they have a problem here. Slope is undefined. So the function is not differentiable at 1. So either I will take this interval or I will take this interval. I cannot take both. So y equals square root of 1 minus x, where x is positive. This is upper half of the parabola. Where the function, where y is defined as a function of x, as differentiable function of x, and I have y equal minus, where x is this, here y is negative, which is the lower. Okay. We know that the slope at 1 is undefined, so we cannot make it equal actually, but also I split the interval into two intervals. Y equal plus, y equal minus. I cannot make it at the same time. Okay, that will lead us to this question. Sin y equal x, which is the same idea. I know if I differentiate sin y equal x, differentiate with respect to x, and to find the largest interval of this form, or y between minus a and a, in which y is a differentiable function of x. I have what? Cosine y times y prime equal 1. That implies in y prime is 1 over cosine y. I need to be careful. Cosine y not equal to 0. Means y, when cosine y equals 0, and notice when I say y between minus a and a, it means y equals 0 is included. Okay. So I need y to be not equal pi over 2 and minus pi over 2. This will be the largest interval. So the largest interval where the function is differentiable between minus pi over 2 and pi over 2. Because if I reach these two, I have a problem here. The slope is undefined. Okay. So y is a differentiable function of x. Y is a differentiable function of x. The largest interval is if y between minus 2, pi over 2, and pi over 2. If I reach these two, I cannot put the equality. The equality slope is undefined because I have a problem here. Okay, like what we did here, the same idea. I cannot have both. Okay. So now we notice something more. Can I find cosine y in terms of x? Yes. Since we know from this that sine the angle y is x over 1. So if I have an angle y, that will be what? X over 1, and that will be square root 1 minus x squared. Also, I notice at this interval, cosine y always positive, which is the first and fourth quadrant. So cosine y is what? Is the adjacent over the hypotenuse, which is square root 1 minus x squared over 1. So it's square root 1 minus x squared. So this one, y prime will be what? 1 over the square root 1 minus x squared. Which is, we'll see it in the inverse, since we are dealing with the, actually in this one, we're dealing like y equals sine inverse of x. The same idea. Okay. Yeah. Okay. These questions find the tangent line to this graph at this point. Actually, yeah, the slope is easier. It's okay. I'll do tangent line. Then I'll do, yeah. I know M tangent is F prime at square root 2 over 2. And they have the point. Either have the slope, the point, I can get the equation. So let us do the calculation. I would differentiate this. Let me rewrite it. X to the power 4 plus x squared y squared equal y squared. I need to solve for y prime, and I have the points. Differentiate with respect to x. What you will get? 4x cubed. Now I have product. 2x y squared plus x squared 2y y prime equal to y prime. You know what? I can substitute right away. Sometimes it will help. Okay. Now I have x equal this and y equal this. So that means what? 4 x cubed, it will be what? Cubed of this, 2 root 2 over 8. And that will be root 2 over 4. Okay. Plus 2 root 2 over 2. Y square. Actually, since I have a square root of 2 over 2 square is half. 2 over 4, which is half. The square root of 2 over 2 cubed, square of this. No, it is, no, not square of this. It will be half times root 2 over, which is root 2 over 4. It will be squared times, yeah, it will be root 2 over 4. I'm plugging this there. 2 root of 2, y square, it will be half. Okay, plus 2 root 2 over 2 times half y prime equal root 2 y prime. Yes. Now do the calculations. This is what root 2. You can simplify it and then substitute. It's up to you. Now this is what? This is cancelled, plus root 2 over 2. Okay, substitute here. Here, no y prime. Here I have y prime. Where we have what? This is cancelled. Where we have plus root 2 over 2 y prime equal root 2 y prime. That means y prime, this is over 1, so it will be 2 root 2, 3 root 2 over 2 equal root 2 minus root 2 over 2 y prime, which is what? 2 root 2 minus root 2, which is root 2 over 2 y prime. I'm trying to simplify it. So y prime equal this over this. 3 root 2 over 2 times 2 over root 2, which is 3. And that is the slope. So what will be the equation? Y minus root 2 over 2 equal the slope, which is 3x minus root 2 over 2. So it means y equals 3x minus 3 root 2 over 2. This take it to the other side, plus root 2 over 2, which is 3x. This is what? Minus 2 root 2 over 2, which is minus root 2. So the equation y equals 3x minus root 2. Passes through this point, yeah. 3 root 2 over 2 minus root 2 is root 2 over 2, which is okay. It's just checkpoints, and the derivative is 3. Okay. Now, hopefully it's clear. Huh? This is the equation. Calculation. Just we differentiate, looking for y prime, do the calculation. Sometimes you can simplify and then substitute, or you can substitute right away. Determine the slope of this graph of this function at the point. So I need to find M tangent, which is F prime at 3 or Y prime at 3. Or I can do it Y prime at the point 3 and 1, because I need Y and X to do the derivative. Let us do the calculation. So differentiate with respect to X. You get what? 6 x squared plus y squared times derivative of this, something squared, so derivative of this, 2x plus 2y y prime equal is product 100. X is 1 times y plus 100 x y prime. Now substitute x and y. X is 3 and y equal 1. So now I have 3 and 1. Substitute. I have 6. This is 9 plus 1 times 10, which is good. Times this is another 6. Zaid 2y prime equal 100 plus 300 y prime. Okay. So we have 60 times 6, that's 360, plus 120 y prime equal 100 plus 300 y prime. So we have take this to the other side, take this to this side. I have 260 equal 180 y prime. So it will be y prime 260 over 180, and that will be 13 over 9. That's it. Determine the slope of tangent line at this point, same idea. Let us do it. That will be easier. Maybe it was, it should be a good idea that I start with this one, not with these two. But it's the same idea. Differentiate with respect to x. You have 2x plus 8 y prime equals 0. So I have y prime equal minus 2x over 8y, and that will be minus x over 4y. Now substitute. You have minus root 2 over minus 4 root 2. This will be what? Minus 2 over minus 4, and that will be half. So that will be the slope. That will be y prime. This is y prime. Here, I'm substituting at this point. Given x squared plus y squared equal to 2, I want the second derivative in this example. So we'll do the derivative 2 times. So that will be 2x in a differentiate with respect to x. You have 2x plus 2y y prime equals 0. So it means y prime equal minus x over y. Differentiate. Yeah, I can differentiate in this one, or I can differentiate in this one. Huh? Let me usually do it with this one. So y double prime equal what? Minus, make it like this. So the derivative of the numerator, which is minus 1 times y, minus x, derivative of the denominator, which is y prime, over y squared. In other words, it's x y prime minus y. Minus times minus, yeah, over y squared. I plug y prime again, so that give me what? Minus x squared over y minus y over y squared. Now I simplify the function. This relation, I have y double prime is minus x squared minus y squared over y times y squared. In other words, it's minus x squared plus y squared over y to the power 3. Notice this one is the same as the problem. So x squared plus y squared is what? 25. That will be the final answer. Do it again with this one. Another problem. Differentiate with respect to x. I have what? 4x cubed plus 4y cubed y prime is equal to 0. So it means y prime is minus x cubed over y cubed. That means y double prime will be what? Derivative of the numerator, which is minus 3x squared with denominator, minus x cubed 3y squared y prime all over y to the power 6. This is just simplified. That will be what? Half minus minus. That will be 3x cubed y squared y prime minus 3x squared y cubed over y to the power 6. Plug y prime. So that will be equal. I can take 3y squared common factor. And they have what? Not only 3y squared. Can have 3x squared y squared common factor. And the remaining is what? X times y prime. What is y prime? Minus x cubed over y cubed. Minus, I took x, minus 3y or plus minus y. Minus y over y to the power 6. So that give me what? This is will be cancelled. I have 4. 3x squared over y to the power 4 times. This is what? Minus x to the power 4 over y cubed minus y. And that will be what? Minus x to the power 4 minus y to the power 4 over y cubed, which is 3x squared. Notice this is what? Minus x to the power 4 plus y to the power 4 over y cubed, over y to the power 7. The same thing. This one is the same as this one. So it's 16. So it will be minus 48 x squared over y to the power 7. 3 times 16 is 14. I wish it's clear. Now for the logarithmic differentiation, if you wanted to find, before the logarithmic differentiation, if I have len, then very clear to me, I can use the len properties before I do the derivative. So that will be len x plus 1 cubed plus len x minus 1 to the power 4. Not only that, that will be 3 len x plus 1 plus 4 len x minus 1. So it will be y. Now I do y prime, it will be easy. It will be 3 over x plus 1 plus 4 over x minus 1. In other words, it's what? X squared minus 1, 3x minus 3 plus 4x plus 4. And that is what? 7x plus 1 over x squared minus 1, which is very easy. Second one, len of what? X plus 5 over x squared plus x plus 1, all to the power 1 over 3. And that will be 1 over 3 times len x plus 5 over x squared plus x plus 1. And that will be 1 over 3 len x plus 5 minus len x squared plus x plus 1. Now we'll do the derivative. Now this, all of this is y, huh? This is y only, huh? Y equal. I did not do any derivative. So it will be y prime 1 over 3, just a number. Derivative of this. What's the derivative of this? 1 over x plus 5. Minus derivative of this. I have x squared plus x plus 1. And this one will be 2x plus 1. You can leave it or you can simplify it. 1 over 3. I have x plus 5 times x squared plus x plus 1. Here I have what? X squared plus x plus 1 minus 2x plus 1 times x plus 5. And that will be 1 over 3x plus 5 x squared plus x plus 1. It's not. Now I can do the calculation there. It will be x squared plus x plus 1 minus 2x squared. I have 10x plus x minus 11x minus 5. That will be what? Minus x squared minus 10x minus plus 4. Yeah, 1 minus 5, minus 4, sorry, minus 4 over this. Okay, I hope it's clear. Now, actually, that give us the idea. And when we do the len and the properties, it will help to do the calculation easier. So why not I take len, and this one, the len is with the function. No, in this one, what I will do, I will take len of both sides. This is my first step, take len. So I have len y equal len the other side. Which is len x minus 2 squared minus half len x squared plus 1. So and I take the len. Now this is implicit differentiation. So differentiate with respect to x. What you will get? Y prime over y, since I'm doing it in respect to x, that will be, oh, before that, I can simplify this one as what? This is 2 len x minus 2 minus half len x squared plus 1. So that will be 2, 1 over x minus 2 minus half. I have x squared plus 1 here, derivative of 2x. And that give me what? 2 over x minus 2 minus, this is cancelled, x over x squared plus 1, where I can simplify it more as x minus 2 times x squared plus 1. I have 2x squared plus 2 minus x squared plus 2x. And that means in y prime will be y times all of this, which is what? X squared plus 2x plus 2 over x minus 2 times x squared plus 1. I can put y now, which is x minus 2 squared over square root x squared plus 1 times x squared plus 2x plus 2 over x minus 2 x squared plus 1. So this is my answer. Differentiate this, the same idea. Yeah. What I will do, take len, have len y equals 3 over 4 len x plus half len x squared plus 1 minus 5 len 3x plus 2. So now differentiate with respect to x. to get what? Y prime over y equals 3 over 4x plus half. This is x squared plus 1 times 2x minus 5. And I have 3x plus 2. No need. Times derivative of this, which is 3. So I have 3 over 4x plus x over x squared plus 1 plus minus 15 over 3x. This is y prime over y. So that means y prime is y, which is all of this, x to the power 3 over 4. Let me write it y, because I need to simplify now this. Times 3 over 4x, or I can leave it like this, plus x over x squared plus 1 minus 15 over 3x plus 2. And they can leave it like this. And they plug y. You can plug y here. This is, you can simplify, or you can leave it, and depends on the answer. I mean, like finding common factor and do this, do that. Okay. Same idea. Take ln, that will be ln y, take ln, equal to ln x plus 1 plus 5 ln x squared minus x minus 1 minus 1 over 3 ln x plus x to the power 4. Differentiate with respect to x. I have y prime over y equal 2 over x plus 1 plus I have 5. Here I have x squared minus x minus 1 times 2x minus 1 minus 1 over 3. I have x plus x to the power 4, 1 plus 4x cubed. So y prime will be y times all of this. 5, 2x minus 1. Okay. Yeah, let me stop here, or yeah, let me do this, then I will stop. Where we have function to the power of function. This is for sure I need to take ln. So I have ln y equal ln x to the power square root of x. So I have square root of x ln x. Now differentiate with respect to x. Get y prime over y. Derivative of this 1 over 2 root x. Then this is a product now. Two functions. Plus root x times 1 over x. Which means y prime will be y times ln x over 2 root x plus 1 over root x. Yeah, this is x to the power half, is x to the power minus half, which I can write. This is y. They can simplify 2 root x, and they have ln x plus 2. This one, take ln. I have ln y equal ln x to the power 2x, which is 2x times ln x. Differentiate with respect to x. I have y prime over y equal to ln x product plus 2x times 1 over x. That means y prime will be y, which is x to the power 2x times what? 2 plus 2 ln x. Yeah. We have more problems with this, so let me stop here. Thank you.